Hello, this is Remington Hub City Home Inspection here for another video. Today we're going to be talking about heating, ventilation, and air conditioning systems. So as we're following this Texas template, we're going to start with heating equipment. We're looking at it, we're going to see, hey, we have a gas furnace, we have an electric unit, is it central heating and air, window unit, mini splits, some of both, and of course just make note, we're looking at the type of system, and then of course one of the important things is how old is the unit. So in my reports I have a note that whenever I put the date in and the name in, when I check those boxes or the brand, it also has a note in there that says something along the lines of Texas states that on average an HVAC system will last 15 to 20 years. And if people ask me how long do you think this unit will last, or does it have a lot of life left in it, or what's the average you see or that we see, and I revert to that. Hey, this is what Texas states as the average that they see on a system that's from the coast all the way up north in Panhandle. And I tell people, hey, the oldest heater I've seen is from 1976, a house in Lake Ridge. I also, comment with, hey, I don't think they make things that well anymore. I don't think any of our current units are going to last that long. And you can get a specialist out here, an HVAC technician, and they're probably not going to give you a expected life either. It's just too hard to know. Obviously, we hope they last a good while, but I've seen things that are really new not last long. And personally, I've had a unit that was 20 years old, 23 years old, and so they may not be as efficient as they were or as the new ones, but doesn't mean it's not still heating and cooling your home. So the age is always important. And then we're looking like, so on a heater, hey, is it producing hot air? Yes, we go to our vents, we take temperature readings, hey, we're getting hot air everywhere. And now everywhere, obviously if it's producing hot air in one place, it produces hot air. The reason we're checking multiple vents is to see if our temperatures are fairly consistent. That just kind of helps us know that, hey, our ductwork seems to be connected well. And then in case we couldn't see something in the attic, or if we haven't gotten in the attic yet. So we're taking temperature readings, hey, we're producing hot air. Now, like on a gas furnace, on the label, there's a temperature rise range. And that range on a gas furnace is usually about 40 to 70 degrees. So wherever we have our temperature set, we have our temperature set at 70 degrees and we're running the heater, then we should see a temperature coming from our supply vents between that 40 to 70 degrees higher than our 70 that we're set at. If we happen to be lower than that or we're way hotter than that, it probably means something's off. Air's moving too slow, and so it's having more time to heat up. And I had this just the other day. Had a return vent, and the filter on it had not been changed. It had a date on it, had not been changed since 2021. We're in 2026 right now. It just the filthiest vent or filter I've ever seen, and that thing was getting very, very high temperatures at the supply vents, because that air was moving so slow through that system. It needed cleaned, the filter needed changed. I pulled the filter out, reran it, and we got good temperatures. So there's variable things. Some of them need a technician, some are worth having somebody out for, and some of them are simply, hey, you need a new filter, the thing needs cleaned. Sometimes it's just easy stuff. Obviously we have a technician out still to clean the unit, but start with the basics. Check your filters, keep them clean, keeps air flowing smoothly. So we're checking temperatures. Are we in that range? Does it seem like it's operating like it should be? We have a lot of gas-fired furnaces around here, excuse me. And so we're looking, hey, when you take the cover off and you can see the flame at the burners, is it blue? Are they mostly blue? We have a lot of flickering or specks in there, or is it pretty consistent? So that kind of tells us how is it delivering gas or delivering that fuel, the orifices on the jets, things like that. Common notes you're going to see on these, where the wire, like we talked about under electrical system, where the wire passes through the housing is metal. Anytime wire goes through a metal housing, it needs to have a grommet or a clamp so that the wire cannot rub directly onto that metal. You'll see that note a lot. Simple fix, very easy, very inexpensive. Somebody could do it themselves if they wanted to. The other thing that you'll see, it's very common, is the exhaust on a gas-fired furnace that goes up through the ceiling and then hopefully through the attic and out of the roof. That is usually touching where it penetrates the ceiling, that sheetrock, it's usually touching the sheetrock. If it's not touching, it's at least closer than modern standards want to see it. If we have a double-walled pipe, which is the common style of pipe that we'll see on a water heater and a gas heater, that needs to have an inch space. So we should have an inch gap all the way around it when we look up next to it. And it's just extremely common not to see that. Even on new builds, even on some new builds, I'll still make that same note. Hey, and it says something along the lines, I just took the verbiage from the code book, something along the lines of exhaust vent pipe too close to combustible materials. So that sounds scary, combustible materials, hey, this can catch on fire. I tell people it sounds scary. I mean, obviously if you want to correct it, that's great, but I've never seen one where the sheetrock looked hot, where it looked burned, looked like it was getting excessive heat. Now obviously it's not designed to have that heat touching it, and it's always better to do it the right way, but I always tell people I've never seen it like it was causing an issue right now. And so they make sleeves and metal skirting, flashing you can put there, so we're touching the metal and we're not touching the drywall, or you can just adjust it, and so it's not touching at all. Very common for these on water heaters and heaters. This is good to know if you ever have a house listed and it gets a new roof. Those roofers, when they redo those penetrations and put new boots on or put new rain caps on, and they have to take the shingles off and the old ones off, and they're putting new on, they mess with those pipes a lot, and they will knock them loose. They'll separate them in the attic at the water heater. They'll get them off so that the draft hood is no longer on, and they will make that may not have been touching before the roof got done, but when they get done, it's very common for it to be touching. So it happens different ways and just over time from people working on different things. Another thing that we'll see on a gas furnace, our gas line, we have a steel gas line. It should have what we call a sediment trap. And it's simply, here's our gas line coming in, it's steel pipe, and then it's going to get to the heater over here. Before it does, we need a leg that drops down, and this leg just catches debris that runs that may be in our line. It may be just a little corrosion, little specks of the pipe, little metal, or it could be debris that's just in the gas system itself as it's being delivered to the home. That leg lets that stuff drop down in there, and it helps lengthen the life of the unit, because now it's not getting clogged in any orifices or jets or going into the burners. It's simply dropping down and missing our system. That's the same with a water heater too. Any gas-fired appliance like that, we want to have that sediment trap there. On electrical, common notes we'll see is the grommet also, just where the wire comes through. It's just a bigger wire. Same thought process. It's just usually a larger wire because we're pulling more power for those electric units. And then we are on gas and electric. Something that we'll see is our secondary condensate line. So we have our pan in the bottom of our unit condensates, or our unit condensates into a pan, and it has a drain line, and it has two drain lines. One sits like this and one sits slightly lower at an angle like this, okay? The idea is this one drains, the lower one drains, but if it ever gets blocked because of junk, it happens all the time, this is a secondary overflow. Water will rise in the pan until it gets to here, and then it will flow out of there, and usually it flows into the pan. This is like in attics units that are laid down up there. It'll flow into the pan, and then in your pan, catch pan, you either have a electronic float that once it gets enough water, it'll rise, and then it senses it, and it clicks off, and it shuts the unit off so it won't condensate anymore. Or you just have a secondary drain line that leaves the pan and runs in our area most of the time to the garage. It's supposed to run to a conspicuous area is how they word that. somewhere that if that line is being used because of a blockage, that you'll notice it. Mine at my house, if you walk out into my garage and you step right onto the concrete from in the house and you look straight up, that's where you'll see mine at. I think 2 different times we've walked out into our garage and there's been water right there in front of us. Now, in theory, that's considered a slip and fall hazard. We don't want it in a walkway, but it's very good to have it very obvious, because even though you know what it is, you have to think for a second, why do I have water in my garage floor in this random spot? It's like, oh, heck, my heater must have an issue. And you call an HVAC person. You may turn it all off and go look at it first and see. Last time it happened to mine, HVAC guy said, man, I'll come out and look at it for you, but I'll tell you what I'm gonna do. I'm gonna hook a shop back up to it, to the main line, and I'm gonna try to suck it, everything out of it, because it probably just has junk in it. Insulation, dirt, just junk. He said, that's what I'm gonna do. If you wanna try that first, if you have a shop vac, go for it. If it doesn't work, then call me. Did it, it worked, and saved myself a service charge. So not a hard fix, but we see these in garages. If I see it somewhere that's not conspicuous, to where it's like, hey, if it ever does get utilized, that secondary overflow coming from the drain pan, they're never gonna notice it. What's considered deficient. We need to be able to notice this. The other thing along with that, now we have these 2 openings. This is our main one, and here's our secondary. What we see a lot is that they have a drain coming out of the main, but the secondary they're leaving plugged. And this has been since, I don't know how long they've been doing this, but for the 5 or 6 years I've been here, they'll leave that secondary plugged. And I called an HVAC company one day, years ago, and said, hey, why is everyone leaving the secondary plugged off? Because normally it just has a little 90 degree, just like this, so water can run and just drip out. And he said, his response was, I'm glad we're not the only ones doing it. He said, the reason we do it is because sometimes those are so close, they're not way offset. Sometimes they're just very close. And if the unit's not quite level, water will come out of the secondary drain even when there isn't a problem. And it makes people think they have a problem when they don't. Then they call an HVAC company. HVAC company charges them a whatever, $170 service charge, or maybe it's an $85 service charge, since they don't actually do any work when they get there. And they say, oh, you don't need us, you don't actually have a problem. That thing just happened to get some water in it, and they were just too close together. Sorry, here's your bill. And so he said, we started just plugging it off, or leaving it plugged. We don't unplug it after we get the units in. And in that unit, in your heater, there is usually it's plastic, there's a pan in there that's just yay deep. And what they're counting on is for that pan, if it's really that bad, they're gonna let that pan overflow and then fall into your main catch pan under the unit that's designed to catch the water. In theory, that works fine. As a home inspector, it's considered incorrect. And so I mark it wrong. My note makes a statement about what I just explained and why they have that plugged off. But we don't want water overflowing out of the internal pan and out of the crevices of the unit. It's fine, they're all doing it, but it's considered incorrect. HVAC guy may say, man, this is why I do it, and I would leave it if I were you. He's qualified to say that. I'm a home inspector. Hey, this is considered incorrect. You can do whatever you'd like with it. Another common note you'll see is debris in the overflow pan. So we have that overflow pan that we just discussed that's sitting on the base, and the unit sitting over it on some bracing. It's supposed to be metal braces that it's sitting on, or risers. Well, if that pan has debris in it, usually it's insulation. Maybe some grommets and some just random little pieces of wood, or just random junk that's just there from maybe someone being lazy, maybe someone didn't realize it fell in there. But we call it out because we have a float. And remember, that float has to rise up, has this piece, and it lifts up, and then once it makes contact, it shuts your unit off. Well, however, if one of these little pieces of debris gets in the way, well, now that thing can't shut off, but it's still filling with water, and it could overflow. And when we're in these situations, normally these are in attics, and it's going to overflow onto the top side of your ceiling, and then you're going to have a leak coming into your house. The other thing, say you don't have an electronic cutoff and you just have the secondary drain coming out. Well, if we get that secondary drain clogged and blocked because of junk in our pan, then now our secondary doesn't serve its purpose. It's no good now. So we want to keep our pan cleaned out, just so water can flow like it's intended to. Let me see here. So window units, I may run them. Just, hey, they're blowing cold air. I don't give them too much attention. Mini splits, same thing. Make sure they're running. I'll take photos and put dates on them so everybody knows how new they are or how old they are. And then on moving on to air conditioners, we're putting the date. Hey, how old is this? People want to know. We're not required to put the SEER rating, the efficiency rating, or the tonnage on it, but just so people can know, I'll put the tonnage, assuming it's legible on the label, and I'll put the SEER rating on there. Then I'll put the brand and the date. And those are the things people want to know. I don't. Most home inspectors don't, and they really shouldn't. Don't size units like, oh yeah, this is the correct size unit for this home. That's not our job. We're not qualified to do that, even though there's kind of a rule of thumb on that. It's just, I just tell people, hey, that's outside of my qualifications. I'm not an HVAC technician, so I'm not going to say it's right or wrong. So we're checking that. We're going to see, is it a heat pump? Is it not? If it is a heat pump, then whenever I run heat, I'm going to run it on standard heater, and then I'm going to run it on emergency heat to see if that condenser, when we're on regular heat with a heat pump, our condenser is going to be spinning. Versus a non-heat pump unit, that condenser won't spin. But then when we put on emergency heat, we should still produce heat, but our condenser should shut off. We're using just the electric furnace at that point, just the electric heating system at that point. So we're checking that and see if that functions like it's supposed to. I talked about tonnage, SEER rating, age, brand. Also going to put the coolants that's in there, the type of coolant, R22, 410A. We've got new ones this year now. And that does make a difference, because if we have a unit from 1998 that's got R22 in it, it's still running fine, but it's really good for a client to understand that we don't have R22 coolant anymore. Those things cannot be worked on as much as a newer unit. And now they're phasing out the 410A, that's just last year. People that had brand new ones last year, their stuff is now getting phased out already. I mean, it's going to last a while longer. I have no idea how long, but they are phasing that out because we have new, more economical, more green coolants out now. And so it's good to know it is running well. Everything's working fine, but it's kind of good to know your unit cannot be worked on as much as a newer unit can, just because of the parts and the coolant that it requires. One of the biggest deals that you're going to see noted, the way that a home inspector tells if a AC is working as it should, is we have our temperature differential. And so we have a supply vent and a return vent. The temperature from the supply vent and the temperature from the return vent, the difference between those two should be between 15 and 22 degrees. If it's outside, if it's 23 degrees, it's wrong. And if it's 14 degrees, it's wrong. Usually, if it's really close, I'll check it a couple times, or maybe in different areas of the home. But if it's wrong, it's another one of those things that, hey, it didn't meet parameters, it's incorrect. And it's recommended to have it serviced by an HVAC technician. Because I have no idea why it's doing that. It may be something extremely minor, or it may be something that is a big deal. And the reason I'm a stickler with it is I've had a house where I wrote on there, differential was wrong. Hey, I recommend you have this serviced. They didn't have it serviced. They called me like a week after they moved in, and their air conditioner went out, and they were told going to have to get a whole new system. And I asked them, I said, hey, my recommendation was to have an HVAC technician come out and evaluate your unit. Did you do that? And they said, no, we didn't. She was texting me, this homeowner, and she just didn't ever respond again. it's a terrible situation, but she knew she didn't do what was recommended, and that could have saved them a lot of money. It maybe wouldn't have, but it could have saved them a lot of money, because then they were out an HVAC system. So that's why there's really, no leniency on it. 1 degree off, it's considered incorrect. It's not trying to be a stickler, but we just don't know why it's doing that always. I don't know why it's doing that. I'm not an HVAC technician. So another common note you'll see is the condenser line, the coolant line. On the outside, it needs insulation on it. That helps it be more efficient. If the insulation's deteriorated, damaged, missing, needs insulation. Super simple. Go down to Home Depot, you can buy some and just wrap it around there, tape it on, you're good to go. The modern standards, we have to have an electrical disconnect within sight of the unit. So wherever our condenser sits, we should either have to look to the left or to the right. On the same wall, we should be able to see a disconnect that a service technician could go and simply pull that disconnect and remove power from that unit. That's an older home thing, but every once in a while in older homes we'll see that still. Another thing you'll see every once in a while is the dryer vent is too close to the HVAC or the condenser, I'm sorry. And that condenser, so we're trying to dispel like hot air maybe, and our dryer vent's blowing out hot air, and it's also blowing out lint. And those two things are going to make that condenser have to work harder than they should, pushing heat to it as well as lint on it so that it doesn't flow air properly. So it's it's one of those things, there's really nothing you can do about it unless you want to pay money to move your condenser farther down or reroute your dryer. But remember, we inspect off of modern building standards, and today those two things have to be separated farther than what we see sometimes on older houses. As far as the duct system, the vents, the returns, things like that, if I can get in an attic, I try to look at all the connections the best I can. Try to have the air or heat running while I'm up there so I can feel air leaks anywhere. Look to see if stuff's excessively taped up. Hey, is our ductwork taped up a lot? It may signal that it's not connected well, and it's barely hanging on by all the excessive tape they have. Do we see gaps in any of the duct board? Just things like that, just inefficiencies. Hey, are we heating and cooling our attic? That's what we're looking for. Let's see. And like I said, the return filter, checking to see, hey, is your return filter dirty? If it is, that makes your unit work harder, as well as we learned earlier, it may make our units not work properly. So that's, for the most part, that's heating, cooling, HVAC systems, and duct work. Again, if you have any questions, let me know. My name is Remington, Hub City Home Inspection. Appreciate you watching the video.